Hey guys, welcome back to the channel. This is the house in Oceanport where I did part one of the 200 amp service upgrade with the automatic transfer switch. Unfortunately, I did not record when I actually put the transfer switch in. I forgot to bring the camera that particular day that I did it, so you'll see it later in this video. But for now, I'm showing you this hot tub that we did. And don't forget, and I did not forget about putting the disconnect within sight of the equipment here, and a minimum of 5 feet away, obviously. One of my previous videos, I did the hot tub and I forgot to put the disconnect in. This one has a disconnect. It's right behind those stairs that you see me just going up there. And what I want to do is I just want to get the cover for this beautiful hot tub out of the way so it doesn't get damaged. But the first thing I want to do is scope out how I'm going to achieve this, the wiring for this hot tub, and that's what I'm doing now. So the first thing I do here is I want to lay out how my conduit is going to sit on this concrete pad, and we're going to do the wiring underneath the deck right here. But first I want to see how this is going to lay out, and I noticed that I got to get to work right away with notching, and that's what this is. So I make that notch a little bit larger than what they gave me because I'm running some 3/4 inch flex here. I have the rigid PVC there also, and we're going to transition from the rigid to the flexible, the Coroflex. Some of you might know it as. Sometimes I call it flexible PVC. So I make this notch just big enough to get the flex underneath where the cover is going to go back on at the end of the day. You'll see in a minute here. And so once I got an idea of how I'm going to do this, I got to complete my PVC run from the disconnect, which you'll see momentarily, obviously, to this hot tub. And I go underneath the deck, and you'll see that in a moment. This was not easy getting underneath this deck. Obviously, it was pretty hot this day, too. So I get hot, I start sweating, and then some of that debris underneath the deck sticks to the back of your shirt. It's not comfortable, but this work isn't easy. But if you're willing to do it, the rewards are fantastic. So I'm running some Schedule 40 3/4 inch PVC underneath from the disconnect to the hot tub. That's what this run is about here. And so I have an idea of what I want to do, and I'm going to push this underneath the deck and then go back underneath the deck to attach it to the other conduit that I've already run. This wasn't easy, and not that anybody's going to be down there, but you want to set this in a position where if somebody does go down there, they don't knock into it, or any animal decides to chew on it, anything like that. So it's up high underneath the floor joist here. And eventually what I do is I cut a couple of pieces so they can match the other piece that's coming from the hot tub. And then eventually you'll mark it, you'll cut it, you'll put a coupling between that, glue it up. Obviously, I don't glue everything until I know how it's going to sit and I'm happy with it before I take it apart and glue everything and make it permanent. Because if you glue it, you're not going to get it undone, even if you try. So you have to cut it out. So this raceway, like I said earlier, goes between the disconnect for the hot tub and the hot tub itself. And I'm probably underneath this deck for about, I don't know, maybe 30 or 40 minutes just getting this right. There's not a lot of room there. You do bang your head once in a while in there. It's not fun, but if you have knee pads and you're willing to do this, just get in there and get it done. You're not going to be in there forever. I always tell the new guys coming up, if they don't like doing this, then you're probably not going to like this trade. But if you're willing to do this, this is where the money is. A lot of guys don't want to do this. They don't want to get inside these tight spots. They don't want to do the hard work. But if you're willing to do the hard work and get in the tight space, get dirty, and be tired at the end of the day, then you will succeed being an electrician. Now, that's a lot different than being an electrical contractor. Some guys are electrical contractors, and they pay guys to do that work, and that's fine. I like to do both. I'm still an electrician. I'm proud to be an electrician, and I've cut my teeth doing jobs like this for my whole career. For 3/4 inch PVC, you're supposed to have a strap every 3 feet. That's in the code section for the PVC. case you were wondering. Yeah, so as you can see, I got awfully dirty down there, but that's okay. I'm all right with that. You really should be using a hammer there to fasten the plastic anchors to the concrete here. But I got to get this done, and I'm doing this today. It's always good to use the proper tools when you're doing a job. But the hammer was not nearby, and so I just used the end of the cordless drill. So this is where I transition from the rigid PVC to the flexible PVC. I'm using what's known as a 3/4 inch female adapter, which is a coupling on one end and a threaded coupling on the other end, which I attach the flexible straight connector to, and therefore you could transition from the rigid PVC to the flexible PVC. That's what I'm doing here. And then I'll come back with the flex and attach it right to that straight connector, as you see here. Here's my main lug only panel that came with the hot tub assembly. Is a double pole 30 circuit and a double pole 20 circuit, and both of these circuit breakers are GFCIs. This is underneath the staircase. There's some of the conduit that I ran that I did not film. The lower conduit is what goes to the hot tub, and the one up on the top is what feeds the sub panel from the 200 amp sub panel in the basement. And you'll see here, there's the feeder, so to speak, okay? There's a difference between a feeder and a branch circuit. A feeder supplies power to a panel, and a branch circuit supplies power to a particular device or a appliance. Here in this graphic, you can see the difference between a feeder and a branch circuit. It should be pretty obvious, but a feeder supplies a panel, and a branch circuit supplies other pieces of electrical equipment. The feeder then goes through the crawl space in this house all the way back to the panel in the basement. So this is my 100-foot polyester snake by Milwaukee. It's fantastic. The best part about it is it's non-conductive. So if you hit some live conductors or some live parts, you're not going to get shocked like you would using a steel fish tape. I really, really like this fish tape a lot. Obviously, it's good for pulling wires through conduits and not snaking up or fishing up walls to pull wires. And so there I am on the other side by the hot tub, pulling the conductors that are set up on a reel. I've got two number 10s, two number 12s, a neutral number 12, and a number 10 equipment grounding conductor. What's amazing about this pull is the number 10 green that I had just barely enough. And as I recall, when I pulled the feeders from this main lug panel to the other main lug panel, my neutral wire was just barely long enough at the panel. I had to extend it, but it reached out of the panel maybe about 8 inches. So that's twice on the same job where the end of the reel was a real thing, and I had just enough to do both. I'm drilling these holes, these anchors for the strap as close as I possibly can to the edge right there. Obviously, we don't want a tripping hazard. All right, so that's why we did that. Now here I am again without the hammer. I really should be using my hammer here. This gets the job done, and I'm not too concerned that this is going to come undone. Also, it should be noted that I'm right next to the Shrewsbury River, which is a salt water river, and I'm using all stainless steel hardware. And so there's my raceway. I think they're going to do some landscaping over that eventually at some point, or I think he's going to do some concrete around that. I'm not exactly sure, but there's my control box. Now, when you're setting these terminals, they're not even terminals anymore. I really don't like this setup. They're like spring connectors here, and you pull down the spring, you set the wire in there. The push connectors. I really would prefer terminals. I don't know. I don't like it. But I got to deal with it, obviously. This is what it is. So as you can see, I stick my screwdriver in there and I push up on the screwdriver so it pushes the spring clip down, which allows the wire to be connected in the terminals here. Not exactly my favorite thing. So there you have it. So I got a 20 amp 240 volt circuit, a 30 amp 240 volt circuit, a neutral that's connected to the 20 amp circuit, and I got a number 10 equipment ground there all the way on the right. That's how the wiring sits inside the control panel. So once the hot tub has been wired, I'm coming back here and I'm hooking up my circuit breakers. So with a GFCI breaker, you don't need to have a neutral connected to the GFCI breaker for it to work properly. But you do need to hook up the tail that comes from the GFCI breaker to the neutral bar. So obviously, when I ran my feeder from the panel in the basement, I ran 4 wires. I ran 2 number 6s, which is good for 65 amps. So this is actually on a 60 amp circuit breaker in the supply panel. I ran a number 8 neutral, and I ran a number 10 ground. So a number 10 ground is sufficient for up to a 60 amp circuit. After all the electrical work was done, I came back and put these labels on there so you know what this particular box is doing. And then on the inside door, it tells you where its power is derived from, which is that main load panel in the basement. Okay, so here's the Oceanport 200 amp service with the automatic transfer switch. Like I said earlier in the video, I did not record this work when I did it, but obviously it's a 200 amp meter we put in. It's a 200 amp automatic transfer switch. It's service rated, and I'm here today updating the grounding electrodes, which is 2 ground rods and of course the copper water pipe in the basement. The utility company here is JCP&L, and they require that if you're going to run that grounding electric conductor on the outside of the house like I have here, that you protect that particular conductor from physical damage. So that's why I ran this 1/2 inch PVC. I sleeved my number 6 copper through the PVC and attached it later, you'll see, to the grounding bridge. Here I'm just tucking this number 6 wire underneath this stone, and I'm attaching 2 ground rods to the same conductor. Obviously, this is the main disconnect, so all your grounding electroconductors go here, including the 2 ground rods that you see me hooking up. Okay, this is the wiring that I did. Up here, that's my line that's my line from the meter on the load side of the meter coming into the line side of the transfer switch. All your grounding and bonding and your main bonding jumper, which is that green wire up at the top there, gets done inside the main disconnect, and this automatic transfer switch is service rated and is the main disconnect for the whole house. So here, that's the bonding bridge that I'm attaching. I like to run the wiring from the ground rods directly through it, and then I'll enter the enclosure right underneath where I'm working here. Both of the conductors, both grounding electrical conductors, the ground rods and the water main will come through the same plastic connector at the bottom and attach to the ground rod inside the automatic transfer switch. The grounding electrode that goes from the automatic transfer switch here, the main disconnect, to the copper water pipe in the basement is a number 2 aluminum. It attaches to the copper water pipe within the first 5 feet. And you'll see that later in the video, the wiring to the water main. Now, there's no meter in the basement, so I'm not sure where the metering gets done. Maybe there's no meter on the outside here. I'm not exactly sure, but there was no meter on the inside. And they have an on-demand water heater that you'll see momentarily when we get down to the basement. But here, I'm just preparing to terminate the grounding electrical conductors on the ground bar inside the automatic transfer switch, which is bonded to our system neutral, which is also inside the main disconnect. Everything inside this transfer switch right now is live. Obviously, you got to use caution when you're doing that, especially when you're holding onto a grounding connector connected to the ground. They'll definitely, if you come in contact with the live conductor while you're holding onto that ground, you'll have some current going through you for sure. And you'll definitely feel it, and you could die very easily. So if you decide to do this at your own house, I would shut everything down, pull that meter, but I didn't hear. Okay, so now we're down here in the basement, and I'm strategically, I use a 2-foot box level right here. I could use my laser level. I didn't break it out. I just used the level here. I just want to get a straight line down so that the grounded conductor that's attached to this foundation wall is straight and done in a workmanlike manner. Obviously, you see there's no meter, but you can see a disconnect valve right there. And then within the first 5 feet is where the National Electric Code requires that we bond to the copper water main. And the copper water main needs to be at least 10 feet of copper inside the earth to qualify as a grounding electrode that needs to be bonded. Here I'm using a brass water ground clamp, and usually I use some emery paper to clean up the copper so I get a nice connection to the copper itself. Remember, you want to bond the water pipe so you limit the potential for current to flow on it. So you want to make sure you get a good bond. That's why you use the emery paper. But this copper was so new that I didn't feel the need to do that. So I put the clamp on there. I'm not sure. Usually I have different clamps, but I decided to use this brass one for no particular reason, only because I had it on the truck. And so what this does here is this bonds the grounding electrode conductor to the actual electrode so that you can limit the current, the potential for current to flow on this copper water pipe and, of course, the water system throughout the house. Guys, thanks for watching this video. This is the end, and we'll see you on the next one.